Okay children, a happy news for you. This will be the last session in semiconductors. I can see the smile on your face. Okay. Be happy that we are going to finish it off today with a few numericals, few questions. Okay. Now you should all know that as far as the CBSE syllabus is considered, we have only up to Zener diode in the chapter. We do not have transistor, logic gates, and anything taken after that one. But in the last year, NEET as well as JEE, they had asked question from those sections even if CBSE has deleted it from their theory syllabus. But of course for the state syllabus there is no such change, the whole chapter is there for you. But for entrance we are not sure, we are actually waiting for the notifications to come. If the notification stays definitely these things are not there, you can be happy. Otherwise you will have to learn everything. But for board examination CBSE, you don't have to learn everything. Fine. Now identify the operation performed by the circuit given below, NOT, AND or NAND. Such questions can be done in two ways. One by using your memory, otherwise by writing Boolean algebra or analyzing the circuit. Okay. Is this familiar in any way? Of course. These are what kind of gates? These are NOR gates. These are NOR gates, and one NOR gate followed by two NOR gates connected as a NOT gate. മനസ്സിലായില്ലേ? ഇത് ഒരു നോട്ടായിട്ട് വർക്ക് ചെയ്യും, ഇത് നോട്ടായിട്ട് വർക്ക് ചെയ്യും, ഇത് നോറാണ്. ഒരു നോർ ഗേറ്റിൻ്റെ ഇൻപുട്ടിൽ രണ്ട് നോട്ട് ഗേറ്റ് കൊടുത്താൽ then this will work like an AND gate. It will work like AND gate. You can study this by heart, you can analyze by giving various inputs here. Okay. That method I have actually discussed in the previous class, but I will do that once again. What you have to do is this. Do not go after Boolean algebra, but that is for the computer science students. You can do that. By using Boolean algebra, this is actually very easy. Because this is A bar, this is B bar. Okay. And here it's a NOR gate. So that must be A bar plus B bar. But here Y is actually complement of this. So that is actually A bar bar dot B bar bar. Negative of negative, think like that. Negative of negative is A dot B. So this is actually an AND gate. You don't follow this method. Rather, you can just work out by writing the truth table. Okay, A and B. Normally 0 0 0 1 1 0. Take an intermediate output here y1 equal to A bar. A here A bar 1 1. Oh, there must be one more input 1 1. So this will give you 0 and 0. Now y2 here is B bar. So B is here complemented 1 0 1 0. Now think about an intermediate here, call it as y dash. See, the more number of intermediate output you take, the less number of mistake you make. Okay. Now y dash is the OR operation of this one, 1 0 0 0 OR operation, and y is the NOT operation on this one, 0 0 1 1 1. Where did I go wrong? I'm sorry, I made a mistake here. It's an OR operation, right? So this output will be y dash will be 1 1 0, and the complement will be 0 0 0 1. So compare the first set of input and the last output, and you will see that it is nothing but an AND gate. Answer, it is an AND gate. Fine. Now next one. The circuit diagram shows the logic combination with the states of output X, Y and Z. Okay. X, Y and Z. Given for inputs P, Q, R and S, all at state 1. See, here all of them are state 1. When inputs P and R changes to 0 with input Q and S still at 1, the states of output X, Y and Z changes to. See here what is asked is that there are three inputs Which are those four inputs? Which are they? One is P, Q, R, S. Then there are outputs like there is X, there is Y, there is Z. Here initially P, Q, all of them were 1. All of them are 1. Now tell me, what is this thing? This is an AND gate. When both the inputs are 1, output will be 1. So X will be 1. X is 1. Okay, because the output here is actually P dot Q, and the output here is an OR gate is R plus S. Okay, now this one here Y is actually the complement of R and S, R plus S, complement. Now R and S are 1. R and S are 1. Oh, sorry, there is a circle here. I'm sorry, there is a circle here. That means this is complement R plus S. Okay, this is OR, not. So this whole combination is only an OR operation. Okay, so when R and S are 1 each, OR operation will give you Y equal to 1. Okay, I'll explain that again. There is a small circle here. So this is a NOR gate plus another NOT gate. So NOR followed by NOT gate becomes OR gate. So Y, output Y is OR of R and S, R plus S. That's what I did. Y is OR, 1 and 1, you will get 1. And what is Z? Z, you can see this is a NOR gate. It's a NOR gate. For a NOR gate, if both inputs are 1, you will get a 0. Because OR gate, both inputs are 1, you will get 1. Then you are complementing it, you will get 0. This is the output. Okay, initial. Now, what is asked? When inputs P and R changes to 0, P and R, Q and S remains. So P will become 0. P will become 0. This will become 1. This will become 0. This will become 1. Now, what is the output X? X is the AND operation of P and Q. So P is 1, P is 0, Q is 1. So X will become 0. Fine. And what about Y? Y is the OR operation of R and S. That will remain 1. Fine. And this is a NOR gate. So when NOR gate has got 0 and 1 as the input, the output will become 0. Okay. Now what? The states of output, you want X and Y, Z, the new value of X, Y and Z. The new value of X1, X, Y and Z is here. It is 0, 1 and 0. Option C will be your answer. Okay. Work out and study. You are given two circuits as shown in the figure, which consists of NAND gates. Identify the logic operation carried out by the two circuits. We have already done in the theory class. Okay, this is a NAND gate. This is a shorted input NAND gate, which is acting like a NOT gate. So this is AND, not. This become an AND gate. And here we know is a NAND gate. This become this become a OR gate. This is AND gate from NAND. This is OR gate from NAND. Okay. Next one. Draw the output signals. Output signal C, not C1 and C2, because this is a question from edited one from exemplar. So you don't have to use two of them. You just write C. What is the output to C when the input is given in this form? See, input can be given in the form means this means 1. This means 0. So in the first interval 0 to 1, in the time interval, because this is time axis, one input is 1, another is 0. Then in the next interval both are 1, third interval 0 and 1, fourth interval 1 and 0, after that both are 0. This is how the inputs are given. Now you can draw the waveform corresponding to this. First of all, what gate is that? What gate is this? This is, you can see, this is a NOR gate, NOR gate, NOR gate. NOR, all of them are NOR gate. So when you have NOR gates like that, okay, this whole thing is an AND gate. It's an AND gate. So the output C should be A and B. That means if at least one of the input is 0, output is going to be 0. If you get a 1 only when all inputs are 1. So that will be very easy now to work out. Okay. Now what you do? You can draw the output waveform for the same interval. The time interval will not change. Okay. See, 1 and 0, 1 and 0, output will be 0. 1 and 1, output will be 1. Both are at a high state, output will be high. If at least one of them is 0, output is going to be 0. So here both one is 0, another is 1, so that is 0. Here this is 1, but the other one is 0, 0. Here both are 0, you will get 0. So this is the output waveform in that one, because it's an AND gate. In an AND gate, you get a high output only when both the inputs are high. Here both the inputs are high, you get high. In all other cases, you get 0. Okay. Now, yeah, same thing in a better way. Okay. Now these are not from logic gates, these are from diode circuits. Diode circuits are important for everybody. Whatever be your syllabus, whatever be the exam you are giving, diode circuits are very important for you. Okay. 220 volt AC is connected between points A and B. What will be the potential difference V across the capacitor? Okay. There is a potential difference of 220 volt AC, and you know 220 volt AC is the RMS value. Its maximum value will become 220 root 2. Okay. Now this one will be forward. This is like a half wave rectifier. Okay. So basically what happens is this. Basically what happens is that you are giving an input like this with a 220 volt RMS value. So if it is RMS value, then you know the maximum value. I'm sorry, I think I'll redo this again. I'll use my finger, that will be better. This is the AC input, and this value, what is this value? Is it 220? No, 220 is the RMS value, the maximum is 220 root 2. Now what is the output of the diode? You can see when A is positive and B is negative, this will conduct. When A is negative and B is positive, this will not conduct. It's a half wave rectifier. So this will give you only this half. Okay. Then this will not come. Then the next half. This is the output. And what will the capacitor do? The capacitor will charge to the maximum value of the input voltage. And the input voltage has got a maximum value of 220 root 2 volt. So the capacitor will charge to 220 root 2. This is actually the capacitor filter that you discussed with the full wave rectifier. Alright. Okay, now there is a circuit here with a diode. What you want to calculate is the voltage difference between A and B. Potential difference between A and B. Chapter current density, if it is thorough, it's very easy. Presence of diode will not make any problem, because this is showing that there is a current flowing. This is a capacitor. DC cannot flow through capacitor. So this is a dead end, no current flow. So the same current will flow through this thing. The potential, the voltage drop across the diode to be taken as 0.3 volt. That means it's a germanium diode. Here there is a voltage drop of 0.3. You can see that among A and B, there is a current, there are two resistors in series, and there is a drop here. So simply sum up all the potential drops there. So I can say voltage between A and B is equal to, okay, PD across 5K plus PD across diode plus PD across the second 5K. And how to calculate the one? PD across the resistor is I into R. So that is 0.2 milliampere into 5K plus 0.3 across the diode plus 0.2 milliampere into 5K. You can see milli and k will cancel because this is 10 raised to minus 3, that is 10 raised to 3. 5 into 0.1 is 1 plus 0.3 plus the other one is again 1. So the answer will be 2.3 volt. Is there an option? Yeah, option B gives you the right answer. Okay. Draw the output waveform across the resistor. Output waveform across the resistor. There is a voltage source which is given as -1 to +1 and there is a diode. Okay. Thing like this, what will happen? It's available here. Okay. If A is positive and B is negative. Okay. Or rather, it's input waveform at A, that's it. Okay. What is given? Input at A varies from +1 to 0 to -1. It varies like that at A. This is the voltage at A, not across this point, at A. So if A is positive, the diode will be forward biased. If A is 0, diode is unbiased, and if A is negative, the diode is reverse biased. So the diode will conduct only the forward bias voltage. Fine. So what will happen? Okay, I'll say -1 to 0, diode will not conduct. 0 to 1, diode will conduct. That's the point. So when this -1 to 0 will not be available. So the voltage available is only between 0 and 1. Okay. So the output voltage should be just like this, but this should start at 0 and go at 1. The negative half, the negative portion will not come. So this is the output across the resistor. Okay. Next one, write the truth table for the circuit shown in figure. Name the gate that circuit resembles. Very important for JEE students. Okay. For that, you should know that there must be inputs given here. And the input is given like normally you will have a terminal here. Okay. You will have a terminal here that is connected to 5 volt. And here you have an option. The option will be drawn like this one. Say there is a battery with positive and negative. Again here there is a battery with the positive and negative. You will have a switch which can be either connected to +5 or connected to 0. Okay. 0 means this is normally represented as a ground connection. Okay. I think it's okay. That means there will be a battery connected and the other end of the battery will be connected to the ground. So this is where you are going to connect A. So, ഞാൻ ഒന്നുകൂടെ വരയ്ക്കാം. ഇവിടെ എയുടെ അവിടെ അങ്ങനെ ഒരു ബാറ്ററി ഉണ്ടാവണം. എന്താ വേണ്ടത്? ഒരു പോസിറ്റീവ് ബാറ്ററി, അതിൻ്റെ എൻഡ് ഗ്രൗണ്ട് കണക്റ്റഡ്. അതുപോലെ ബിയുടെ അവിടെയും ഒരു പോസിറ്റീവ് ബാറ്ററി and the other end is ground connected. The A can be connected to +5 or to the ground. A can be connected to +5 or to the ground. That's it. Okay. Now, logically, 1 means positive connection, 0 means ground connection. 1 is positive, 0 means ground. Okay. Now, let us see what will happen if you connect this to ground. This +5 volt will have one terminal connected to the ground, other terminal is +5. So, effectively what is happening is that you are connecting a battery with a negative positive here like this. Okay, നോക്കിക്കോളൂ അതിൻ്റെ കോൺസെപ്റ്റ് പറഞ്ഞുതരാം. ഇപ്പോൾ എ ഗ്രൗണ്ടിലേക്ക് കണക്ട് ചെയ്യാന്ന് പറഞ്ഞാൽ അത് എന്താ സംഭവിക്കുകയെന്ന് അറിയാവോ? എയുടെ സൈഡും ഇങ്ങനെ കണക്ട് ചെയ്തു എന്നർത്ഥം. Okay, so what will happen? This diode will be forward biased. ഇത് forward biased ആവും. When this is forward biased, diode will conduct. When diode conducts, you can see that this point will have same potential as this thing. That means it will have 0 volt. If the diode conducts, the potential at V0 will become 0. അതെങ്ങനെ മനസ്സിലാവുമെന്ന് നോക്കിക്കോ. ഇത് റെസിസ്റ്റർ ആണ്, ഇവിടെയാണ് ഔട്ട്പുട്ട് വോൾട്ടേജ് എടുക്കുന്നത്. ഓക്കെ, ദർ ഈസ് എ ഡയോഡ് ഹിയർ ആൻഡ് you are connecting +5 for that point shown, ആൻഡ് അതർ എൻഡ് ഇങ്ങനെ കണക്ട് ചെയ്യുന്നതിന് പകരം ഇങ്ങനെയാണ് വരേണ്ടത്. ഇഫക്റ്റീവ്ലി ഇങ്ങനെ വരും. അതിന് പകരം ഞാൻ പറയുന്നു ഇതിൻ്റെ ഒരു എൻഡ് ഗ്രൗണ്ടിൽ കണക്ട് ചെയ്തിട്ടുണ്ടാവും, ഇതും ഗ്രൗണ്ടിൽ കണക്ട് ചെയ്തു. വാട്ട് വിൽ ഹാപ്പൻ? ബോത്ത് ആർ ഇന്റർകണക്റ്റഡ് മീൻസ് a current will flow like this. Okay, now the diode is conducting. A conducting diode is like a short circuit. So that means V0 ഇപ്പോൾ എങ്ങോട്ടാണ് കണക്ട് ചെയ്തിരിക്കുന്നത്? ഗ്രൗണ്ടിലേക്ക്. ഗ്രൗണ്ടിൽ കണക്ട് ചെയ്ത് എത്രയാണ് പൊട്ടൻഷ്യൽ? 0 വോൾട്ടാണ്. ഇതാണ് അതിൻ്റെ ലോജിക്ക്. ഇത് മനസ്സിലായാൽ അത് എളുപ്പം മനസ്സിലാവും. ഇത് മനസ്സിലായാൽ അത് എളുപ്പം മനസ്സിലാവും. ഓക്കെ ഓക്കെ നൗ തിങ്ക് this is +5. If this is connected to the ground, okay, then voltage here will become equal to 0. Similarly, if the second one is connected to the ground, voltage here will become 0 volt. Okay. That means if at least one of them is connected to the ground, you will get 0 volt. So, A, B, output V0. A connected to the ground, 0. B connected to the ground, 0. Both will allow the diode to conduct and the voltage will become 0. So output will become 0. Now A is connected to the ground, B is connected to +5 volt. Okay. ഇനി ആലോചിച്ച് നോക്കൂ, B +5 കണക്ട് ചെയ്താൽ എന്താ സംഭവിക്കുക എന്ന് പറയൂ. If B is connected to +5 volt, then the diode has got a +5 on this side and +5 on this side. So both the sides high potential means diode will not conduct. But A is connected to the ground, this diode will conduct. If this diode is conducting, this point is connected to the ground through that diode, so this will become 0 volt. Okay. Now the reverse, 1 and 0. What is 1 and 0? I'll tell you. 1 and 0 means A is 1, A is connected to +5. See this diode D1. Left side is +5, right side is +5. It will not conduct. But this is connected to the ground, 0. So this diode will conduct. If a diode conducts, this point will have 0 volt. It's connected to the ground, so that will give you 0. What will happen when both are, what is this? Okay. What will happen if this is connected to +5 and this is connected to +5? Then this diode, both D1 and D2 will have no potential difference. They will not conduct. So what happens? This is like an open circuit. I'll tell you what happens. നോക്കിക്കോളൂ. ഇപ്പോൾ this is the first diode, this is the second diode. Okay. This is connected through the resistor to +5 volt. When this is connected to +5, this diode will not conduct. When this is connected to +5 volt, this diode will not conduct. So if there is no conduction, there is no grounding effect, this point will show the high voltage of +5. So when both are connected to high, the output will be high. So what circuit is this? This is a logical AND operation. It is a logical AND operation. Watch this video again and again if you don't understand. This is important for the JEE students, not for the NEET students. Explain why elemental semiconductor cannot be used to make visible LEDs. The working principle of an LED is that it produces light by electron hole recombination. Electron hole recombination. Electron hole recombination releases energy. How much energy? Energy of the photon emitted, h nu, will be less than the energy gap, a little less than energy gap. Okay. Now if you want visible LED, the photon energy must be 1.8 electron volt to 3.1 electron volt for visible light. Okay. But elemental semiconductor means silicon and germanium. The energy gap of silicon and germanium are less than 1 electron volt or approximately 1 electron volt, 1.2 and 0.785. So they produce energy only in the infrared region. That's why we go for the compound like gallium arsenide who has better energy gap, they can produce photon in this range. Okay, it's a question from NCERT. 3 photodiodes D1, D2 and D3 are made of semiconductors having gaps 2.5, 2 and 3. Which one will be able to detect light of wavelength 6000 Angstrom? This is a photodiode. What is the principle of photodiode? Electron hole pair, EH pair production by incident light. That means the incident photon should produce EH pair. What is the condition? The incident photon's energy must be greater than or equal to the energy gap. It should be greater than or equal to energy gap. Fine. Or this incident energy can also be calculated as Hc by lambda must be greater than or equal to energy gap. And if you want quick calculation, there is a shortcut. What is that? This energy in electron volt can be calculated like I say energy of photon in electron volt is given by 12,400 divided by wavelength in Angstrom. So you can calculate the energy in electron because these are given in electron volt. So the incident energy, this wavelength energy can be calculated in electron volt using the shortcut equation 12,400 by wavelength in Angstrom. So let us calculate the energy first. What is that energy? You can see that this is equal to 12,400 divided by 6,000. So that is 12.4 divided by 6. That's around how much? 6 2s are 12, 2, then how much is that? 2 point something, 2.1, not 2.1, 2.08 something, right? Maybe something little greater than 2, Okay, so which energy gap, this should be greater. And you can see that this is approximately 2 and this one is 2.5, energy gap is more. Here this energy gap is also more, so the only possibility is with the 2 electrons. So D2 will detect. Detect means when light falls on it, there will be a change in current in the case of D2, but not in the first one and the last one. Okay, condition is this: the energy of the incident light must be greater than the energy gap. Energy of the incident light we calculated something a little above 2, not 2.5, so it can produce EH pair only in the second one. Okay. Next one, again a question from exemplar, I guess. There are diodes, 3 diodes. Their forward bias resistance is 25 ohm. Okay, which one is forward bias? First of all check. This is plus side, so this is forward bias, this is forward bias, this is reverse bias. So in your circuit you have only the first one with 125, then the last one here with 125, and there is a battery of 5 volt, there is 25 ohm. So this is 125, 125, this is 25. But each diode has resistor. So that you can say this is forward bias, so replace it by its resistance. This is 25, this is again 25. So 150 and 150 in parallel gives you 75, 75 in series with 25 gives you 100, so that will become 5 by 100. 5 by 100 is the total current. So the total current I1 will give you 5 by 100. I1 is this current. 150, 150 parallel 75, 75 in series with 25, 100, 5 by 100. This current is 5 by 100. Okay, 0.05. Now I2, I3 and I4. Okay, I2 and I3. See, this current will equally divide here. This will equally divide. So we can say I2 equal to I4 equal to half of this thing. Okay, that will become 5 by 200 each. What about I3? I3 is a reverse bias diode. Current is going to be 0. A very good question in diodes. Next one, again from NCERT exemplar. There is a alternating signal 20 sin omega t connected through a diode to a circuit like this. Okay, this is the input voltage and this is the output. The question is that draw the output voltage. So I am not presenting the entire question. The question is here. assuming diode to be ideal, what is the output waveform? So the output waveform will be like this. Okay, I'll explain why it is. See, this is 20 sin omega t. This voltage represented by this graph is available across these 2 points. Okay, and you can see that there is a 5 volt supply here. The diode will conduct only when the potential difference is, when the potential here is more than 5. Why? Because already this point is at 5. So if you give plus 5 here, what happens? The potential difference is not there, so diode will not conduct. So the diode will conduct only when the potential at, okay, see, if you take this diode, if you take the diode, there is a diode here, and on one side, negative side you have plus 5 volt. And what voltage is required? The voltage here must be more than that voltage. So if this is plus 5 volt, this is unbiased. If this is 0 or 4 volt, 0 volt or 4 volt, this is reverse biased. So the diode is forward biased only when the potential, this point, is greater than 5 volt. Okay. Now you have a alternating signal 20 sin omega t. That means the peak value must be 20 root 2 volt. So from 5 volt to 20 root 2, that's the point. Okay. When the input is 5 volt to 20 root 2, diode will conduct. When diode conducts, what happens is this: when diode conducts, you can see the diode is a short circuit. Diode is a short circuit. Okay, so what is the output voltage? 5 volt it starts conducting. 5 volt it starts conducting. See, 0 to 5 volt diode will not conduct. If there is no conduction in the diode, then what happens? It's very simple. ഞാൻ ഇതിനെ രണ്ടായിട്ട് വരയ്ക്കാം. ഇതാ ഇങ്ങനെ. ഇതൊരു condition ആണ്. These are the two conditions. If this will happen when the voltage at P, or sorry, when the input voltage is less than 5 volt. Less than 5 volt, what happens? Diode will not conduct. This voltage is available here. Whatever input you give, it's available here. That's why the output will have the same thing, input voltage, like this. But what about it's greater? When it is equal to greater or equal to 5 volt, what will happen? Then the diode will conduct and the output voltage will be exactly 5 volt. So it cannot increase more than 5. So the upper part is removed. It's called a clipping circuit. It clips the upper part. Okay. Again, important for JEE people, not for the NEET students. Okay. Anyway, these are few questions from the exemplar book, NCERT exemplar workout. As a whole, the chapter is not very difficult unless they use such kind of questions. But this can be expected only in the JEE mains and advanced, not in the NEET examination. So, thank you so much for sitting through all these episodes. Hope this will become easy for you. If you provided you study that very well. Okay. See you in some other class. So, thank you for your time. Tata.